before anything, we need to we need to fully understand how the shell that we use actually works, okay? And that's the most important part. So that's where we are going to begin with how the shell works. And by now, we all have been using shell or the terminal that we have been using, whether it's the sandbox or one on our local machine. We've been
Sorry,
practicing with it
sorry,
in
Doc.
one way or the other. Yeah,
Doesn't mean that it's recording now.
yes, 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 it is.
Okay.
All right, sure. So, as I was saying, we all have experience with using the shell, but the question is internally or behind the scenes, how does the shell work? Because if you don't know how the shell works, it's going to be difficult for you to do one of your own or create something of that sort. I realized that that was the biggest challenge that we're having from the printf project. Unfortunately, some of us didn't fully understand how it works. So let me focus on the shell. We really do not know how it works behind the scene. But then we are just going on to use the platform, what the ALX platform is offering us to try and do those things. Like tax by tax. And that's not the most efficient way to go about it because we need to appreciate what it is. So with our basic knowledge, maybe one of us should just describe how the shell works. Like what you've seen it do so far. How do you think it works? Let's share. It's supposed to be a brainstorming session, so let's share ideas on that. Yeah, anyone.
I think it's something that works like a prompt, as in
Okay.
is kind of it will it will work like a prompt, and then I require you to put in a command, kind of a
Okay.
command that is already installed in that particular shell or maybe the system. Then
Okay.
you put the command, then it returns back to another prompt waiting for the
Okay.
command. If it's when you are asking for a result, that's, let's say,
Mm.
a C file that you have compiled and saved to another file, and you want to run it, it will be able to run and still come back with the prompt line, waiting for you to do another thing without
Okay.
going to sleep. I
Okay.
think that's that's the simplest way I understand.
All right. So what I like from what you said is the fact that you mentioned there is a prompt and you input command. So basically, a prompt is like is giving you the avenue to type something. So you are alerted to type something, then you go ahead and type a command there. Okay, but how does the shell knows or understand the particular command that you have given it? So for instance, if you go and you write a command like touch, then you say something maybe name.txt. How, like in our own opinion, how does the shell know that it's supposed to do something like this with this command? What do you think?
I think it's basically about the built-in functions, the built-in command. Sorry, if that
Okay,
particular shell knows that I have so and so so stuff, once you put in the stuff that it has in one of the files in the in the shell, then it has to execute it. If it doesn't have it, then maybe it will come up with error that file not recognized, or command not recognized, or something like that.
okay. So you also mentioned built in. Yes, any other opinion on how the shell is able to know exactly what to do with such a command? Any other opinion on that?
Ah, okay. Let me go to the first question. How the shell works.
Okay, okay,
From my own understanding, the shell is just a channel we use in communicating with our computer,
okay,
and maybe a version control like the Git and other version control system. And the shell
okay,
is a easy way for we to communicate with our computer. You can go into our memory of the computer. We can check things out in our operating system.
okay,
Then secondly, like you said here, how does a shell understand the different commands like the touch, like the ls, and I think these commands are being programmed. The commands are being programmed just like a master that they are building programs that they understand all these. That touch is to open a file, ls is to list out the items we have in a directory, and so on and so forth.
okay. All right, that's one noted. All right, I like the points that have come so far. What I'll add on is the fact that when we take a look at the shell, in fact, we probably have to get some basics from operating systems, like learning from the ground up. You need to know what an operating system is, how the machine itself works. Okay, like if you pick any computer at all, how it works, then we'll talk about the the machine has the hardware and the software part, but there is something we call the kernel. Okay, the kernel, which is like what is interlacing between the software and the hardware. So when you put some commands or you do some things that will need the keyboard, I mean the hardware part of your computer to do something, there's a kernel that will pick the instruction, interpret it, and cause the hardware part to also do that. But the shell is basically the interface that we get to be able to communicate with probably the kernel, okay, or the operating system itself. If you want to be able to interact with the operating system and let it do things for you, if you want to be able to effect some changes or get the hardware part of your computer to do something, then you do it through the shell. Okay, so it's just that interface. But when we look at the shell too, we have like the graphical user ones, we have the command line. So what we are looking at right now is a command line one. That's what we are interested in. And basically how it works, as we have said, is that when it presents you with a prompt or an interface for you to enter what you want to do, and is able to interpret the commands. If the command does not exist or it doesn't understand, it tells you that okay, this doesn't exist, or it doesn't make sense, or I don't understand this. All right. But when we go deep into it and we look at how he's able to appreciate this, is that um, each of the commands that the shell knows about. So as Tony was saying that they've been programmed. What's actually happening is that these are files. Okay. So each command that you issue in Linux is a file. So if I write ls is actually representing a file. There is an executable file in your Linux system that has been called ls. Just like when you write your C programs and you compile them, I can write a C program and compile it and call my that program ls. And what that program will do is list some files. I can actually do that. I hope we appreciate that. The same way we wrote a C program that sums up values. Okay, so maybe you wrote a C program and you called it sum. And anytime you compile it and call it sum, and anytime you run say dot sum or just type even the name sum there, it gives you the sum of the two numbers. Or you write sum 5 plus or 5 and 10, something like this, depending on how you programmed your C program, how you wrote the code or the functionality is able to give you the outcome you are looking for. So this is an executable file. In the same way, all the commands that we learn in Linux is or are what executable files. That's where the basis comes from. So if you write touch something, touch, which is the first thing that you write, the command, is a file. So your shell will have to go into the various directories that it has been passed. We know they are all determined in the path. So there is a global variable called path, and we have a list of all the how is it called? A list of all the directories that the Linux or the shell has to go and look for this file that you are looking for. So when you call touch, we'll go through all of them, starting with something like user bin. User bin is a directory. Okay, so we are going to look inside this directory to see, can we find a file called touch here? If it is not here, usually the paths are separated with columns. There will be another part, column, another part, column, another part. So we'll now go to each of these directories and go and find this file called touch. As soon as we find the touch, then we will execute it. So behind the scene, that's exactly what your shell is doing. That's the simplest explanation I can give for how the shell does what it does, how it's able to interpret the commands that you write. So basically what we have seen is that the shell will what? Receive a command. It receives a command. Obviously, when you type it in there, there should be a way for it to pick everything you've typed in there. So it's able to what? Read a command that you give it. Then now to interpret the command, the shell will go and search the various search directories for files relating to the command, files relating to the command you entered. Once those files are found, it's going to execute the file. And by now we have learned that, for example, when I gave sum, depending on how I write sum, I could have used argv to pass some parameters to sum. Okay, so I could do sum 10 and 5 and 10. Then at the end of the day, this is going to be able to pass the outcome to me. Okay, so the files or the command that we are going to be given also can take some options. Depending on how the file was written, they would understand it. So they will know exactly how to execute the command because it is a file that you are running and the file has pre-programmed details in there. Okay, so basically that is what we are going to be doing. Unfortunately for us, with some of these commands that we are talking about, say ls, touch, and co, all these files exist. We don't have to go and create them. Once we have a Linux operating system installed and we are going to run on it, we have these files available to us in the same path where they were. Okay, so ls will be found in user bin ls. It's there. We don't have to go and create it and explain what it is. So for us to create our own shell, our concern is not coming to create this command because this already exists. However, there are some commands that we call them built-in commands. And with the built-in commands, they are not files to be executed. So for them, if you are creating your own shell, you have to explain what they do. So an example of the built-in command would be cd, which is change directory. It is not a file. So you would have to explicitly write what cd has to do. So that at any point in time, when somebody writes cd in your command, in your shell as a command, you will interpret and execute something that you want. I hope it makes sense. So there are two types of commands that we are dealing with here. There are the executable commands and there are the built-in commands. Basically, you can say they are all executable, but I'm trying to differentiate them. So they are the commands that are files inside our Linux operating system. They are made available to us. Then there are the built-in commands. So for the built-in commands, in fact, we can create our own built-in commands. I can configure my shell such that anytime somebody writes obed, it prints out members of this group. I can do that because it is my shell that I'm building and I decide to put in the commands that I want to put in. But here we are trying to create something similar to the standard shell, that's the bash shell that we've been using. So we wouldn't be doing anything outside that. Almost everything we are going to be doing should be related to what the bash shell presents for us. Okay, so let me summarize what I've just said, that there are two types of commands. Okay, that's what I've said. There are two types of commands. We have the built-in commands, and with the built-in commands, we are going to define. So let's say we are what? Developer. So let's say developers defined, say something like that. Then there is the executable files that are available, executable files that are available. So we just need to call their names, call by their names, by names. Great. So these are the important basics that we need to understand to be able to write our code. Any concerns on what we've said so far?
Yeah, Doc, I have a concern here. When you
Okay.
say that commands are file, like for instance, you mentioned of the ls command and the other. I don't
Yeah.
really understand when you mean they are files.
Okay.
Can you elaborate more?
Okay. So there are directories that contain, like, it's a file, just a normal file that you know of. Okay. So assuming now I go, then I create a file. It could, like, let me use C is what we've learned. So you create a C file called sum. Okay, sum.c. Inside sum.c, you are going to write a function that takes the values presented in, say, argv. Okay, that will pass the arguments that will be passed to the main function, then sum them up. Assuming you are going to do something like that and sum them up. Good. When you are done, what do? You compile this code, compile the code, okay, the source code, and into an executable file. Okay, so assuming this executable file, you called it sum. If I'm on the shell and I want to run this program, I can just call the name sum and it will what? Run the program for me. Do you get that one? That's what we've been
Yeah.
doing all this while with our C. Okay, so if you get that one, what's actually happening behind the scene with our shell that you've not been seeing is that when somebody writes ls is actually a file somewhere that you are running, except that you didn't even know that it is a file somewhere. So it's an executable that they have already written that knows exactly what to do. Okay,
Okay.
so now when you call, anytime you say ls is actually calling that file, because the file is an executable file. It is executing it and ending up doing what it's supposed to do. Anytime you go and say touch is a name of a file, okay, and that file is being rendered, and when it's rendered, you know that something is going to happen behind the scenes. Like, once we are learning these things, or by the time we are done building our shell, you realize that we'll use commands like write and read. Those are the ones that you use to actually write something or create something. If you want to create something, you use these ones to write or read things. So when you are using echo, echo is a file. So you go in there and you realize that echo has been implemented. Say it is a C program that was written using write file or write command. This is more of a system command. Okay, but these are files that are available in our Linux system, and anytime you call their name, they just execute, and they can also take parameters the same way these files can also take parameters. Are you getting it now?
Yes, I get it now, doctor. I get it now.
Okay. Okay, so that's
So
what
so that
we
so,
have to know.
so that
Go ahead.
means they are programmed files. There are files that are programmed to perform specific function.
Yes,
Maybe to list out the content of a particular folder or directory.
exactly.
Okay,
Exactly.
okay, I understand now.
So if you run ls command on Windows, Windows command, how is it called? CMD,
Hmm.
command prompt. Yes, Windows command prompt. You would realize that the command doesn't exist because that
Yeah,
file
show
doesn't
errors.
exist in your Windows system, operating system. But in a Linux system, it's available. So that's the difference. Windows has its own. If you want to list files in Windows, it has its own command. Something something del. I've forgotten. You but that is the file in there that the shell will go and see. So if you type anything, so any other command that we type that it brings out that command not found or does not exist, what it means is that when it checked all the path that we gave it, it's not available. If you have any experience with working with Python, so let me say it anyway, even if you don't have an experience, because soon we will start working with Python. You realize that when you install Python on your computer, you would need to explicitly add that Python files to add to the path, your environment variables, the path one, you need to add Python to it. If you don't add Python to it, even though you have installed Python on your system, when you run the Python program, it will now tell you that it doesn't understand this command or this does not exist. Okay. The reason being that it went into the path. It's only the path that is going to be checking. So it's going to check all of the directories that have been stated in the path. Do we get it? It's going to check all the directories that have been presented to it to see if a file like that exists. If it finds a file like that, it's going to come and execute it for us. But if there is no file like that, then we'll give you the error message. So when we say we are building our own shell, we are not now going to be creating functions like touch, echo, ls. No, these are already available to our Linux operating system. So this means that the shell that we are going to build, if we have it or we use it in any Linux operating system, these functions should work. In the same way, even though I'm not too sure, I want to believe that that shell that we built, if somebody is using it on a Windows system and they execute commands that the Windows operating system understands or have files of, they should work. Does it make sense? So at the end of the day, we are just creating an interface where you are able to what? Put a command. Then we are able to read that command that you've put there and pass it to the kernel. The kernel knows what to do with it. It knows that let me go and search through this path. All these paths are available. So I have to search through all the various directories and see this thing, this command that the person has brought, is it available to me? If yes, then I'll click on it, I'll open that file and execute it. So that's the basics that we need to appreciate. It's as simple as, well, we need a user, the end user, or the person using our shell to type in something. So we should give them a prompt, let them know that we want them to type something. Then when they type it, we should be able to read that information and pass it to the kernel. So the kernel will get exactly what they read. Then this kernel, after getting exactly what has been read, will go ahead and look for the file that corresponds to it and execute it to us. But I also mentioned that there are some commands that are not necessarily files in there. There are some commands that we would have to go ahead. So when we say somebody writes CD, we have to write the code and say that what does CD means. So if I decide to write a code such that when somebody writes CD, when the command is CD, you should print sorry. I can decide to code my shell like that. That when somebody says CD, when somebody types CD, print sorry to the person. Okay, so these ones are not files available, but they are built into the shell itself. So whoever is developing the shell will have to write the code for it. So depending on the scope of our project will limit us to the number of built-in commands to write. Okay, and if we want, we can expand it and write as many built-in commands as we want. But since we'll be using a guide, we'll be following that guide to help us do that. I hope it makes sense so far, what we've done so far.
Yeah, that means
Yes,
Doc.
yes.
In
Yeah.
essence, these built-in files,
Mm-hmm.
if it's possible to cut them to see what is inside, it's just like cutting a file. You can see what is inside, you know what's up inside.
That is when you are talking about the built-in ones.
All these built-in, no LS and the rest, all those
No,
files.
okay, for these files,
Mm,
it should be possible, but the challenge is that they are executable files. And you know
yeah,
what
yeah, yeah,
executable
yeah,
files are.
yeah,
You
yeah,
get
yeah,
it? So
yeah.
if you would be able to read one and two one and zeros, if you be able to read
Yeah,
the
yeah,
one
yeah,
and zeros, then you get it. But that's what
yeah,
it
yeah.
means.
I understand.
But what it also means is that you can also create your own file, put it in that directory. Then when they call the name of the file as a command on your Linux system, it would work.
Okay, okay.
So that's what it means.
So you
Okay.
said the types of commands are built in and mm,
We have built-in commands. The other one, I don't know if there is a special name for it, but I was just trying to differentiate them. So I said the built-in commands and the executable ones. Okay, just saying executable because those are files that has to be executed. That's basically why I classified it as such.
yeah, it's fine. It's fine. It's fine.
Okay, good. So in essence, with our shell that we are going to develop, there are three main things that we need to do. Three main things. The three main things are first, our ability to read what a person types. Because if we can't read it, we can't make any sense out of it. That's the very first thing we need to do. Be able to read the file. Then after reading the file, after reading the command that the person wrote, assuming I wrote, say, echo my name is, okay, something like this. It's not just one thing that I wrote. So once you've been able to read it, the next thing I want to do is break these commands into individual words. Do you get it? So if you wrote, say, CD, then you did dot here, I should be able to pick that there is a CD here and there is a dot here. If you wrote, let me use the echo sample this readme. It makes the whole thing interesting. You should be able to pick that there is echo here, There is a string here called sample. There is this greater than sign, which is used for what we call redirection. Redirection. So later we'll have to look at what redirection is and how it's done. Then there is this one too. So what I'm saying is that we should be able to break whatever the person writes. We should be able to break it down into separate words so that we'll be able to interpret the words one after the other, then know exactly what we have to do. Do you get it? So technically that is called parsing. Parsing. Or the other term that you used to call it is tokenization. So you want to tokenize them, make them into tokens. That command that the person typed, you are tokenizing them or you are passing the command. Okay, then after these things have occurred, now you now have access to each individual word or command that the person entered. You want to execute them. So those are the three basic things that your shell does. You read, you pass it or tokenize it, then you execute. But obviously the execution wouldn't be a straightforward thing to do because it depends on what a person typed in. Is it a built-in command? If it is, how do we execute it? Is it one that has to look for a file in a certain path? If it is, how do we have to do it? Is there redirection in there? If there is, how do we go about it? And all those things, piping, flags, all those things will now come in. Okay, so it means that we'll spend a lot of time on the execution. In fact, the execution is like the biggest deal because as for reading, we can easily read. We just need to know what commands are we going to be able to use to read what a person has written. Then for the tokenization too, we just need to know what command are we going to use or what function are we going to use to tokenize the things that we have read from the shell or the prompts. Okay, then we'll come to the execution itself and we'll take a look at all of those things. But more importantly, before any of these can occur, we need to make our shell user friendly. So we need to present a prompt to the end user for them to be aware that we are about to do something or we expect them to do something, type something. So you give them that prompt. The prompt can be anything. You could even start by saying, start typing. Like that could be a prompt. You decide what you want your prompt to be, okay? But since we are trying to emulate the bash shell, we have to look at how the prompt for the bash shell looks like, then we would implement it as such. If I remember correctly, usually when you are typing the bash shell, you have the dollar symbol, then is it blinking? I don't know if it's blinking, but it will be there. Then you know that, oh, now it's time for me to type. Then you start typing. Okay, so we are also going to implement something like that. Sometimes you have your username here, username before this. Okay, and username and probably group that you are attached to or the type of account, whether it is a root account or location, whether it's you are in the root or you are in the home. Usually you display all of that. So we can also implement a such that we display all of that before the dollar sign and let the person now go ahead and type what they want to type. After they are done typing, we are going to read. So we need to know what function can we use to read it. After reading it, we need to tokenize what we read. After tokenizing it, now we have to go ahead to what execute the commands. Hope that makes sense.
Yeah.
Okay, good. So yesterday I tried to come up with a flow chart to make the discussion easier. All right. So this is how it's going to be like. We start from start. Okay, that's how every flow chart begins. So I mean, start here will represent we showing the prompt for the person, or a person opening our program. Once you open our program, what is it? Remember that it's a C program. So you would write your code and compile your code. Then now you give the executables to anyone who is going to use it. So assuming that you are building the shell, you build it, you compile your code, then you give me the executable. That means now I can run that your code on my computer. And when I run your code, that is me starting it. The first thing is there is a prompt for me to input the command. To assume I only write ls. The first thing that we need to consider is what you have typed, the command that you have typed. Is it exit? So exit is actually one of the inbuilt functions that we have to write. We have to write and tell it what should I do when the command is exit. Because bash shell, when you write exit, it ends the shell. Do you get it? It's just because we are trying to implement what the bash shell does. So this is like a flowchart of how the bash shell works. So we need to understand it. I've explained that there are three major things that we need to do. It means if the person has input the command, the first thing is you prompted them to input it. Then you read. You get it? You're going to read, then you pass it. All right. But even before you pass, no, I think even this one, the person should even go. I mean, the tokenization should begin right after reading it. Then you now ask yourself, the first command that the person wrote, is it exit? If it is exit, then you terminate it. Okay. If it is not exit, the next thing we want to ask, is it a wildcard character? Hopefully by now we know what wildcards are. At least if you don't remember at all, you should remember asterisk. If I do asterisk.c, what does it mean? Asterisk.c, what does it mean?
Just to take care of all the .c files,
Thank you.
all the .c
So,
files.
so this is a wildcard that tells you that everything, every file with the .c extension, because we did .c. So we would also have to be able to interpret it. Is it a wildcard character? If it is, then we have to go and deal with the wildcard. Like we should go and explain what they are, explain and work on it. And that process is called globing, wildcard globing. Okay, so being able to interpret and do exactly what the wildcard is supposed to do, or expanding the wildcard. Because if you said asterisk, meaning everything, then over here I'm going to pick all of them. Then I'll now present it to the next step. Okay, so the next step here that we noted is the passing. So we are now going to pass the command to like the executable. But even before we do that, we want to check that thing that you are bringing. Is it what we refer to a pipe, or is it a redirection character? If it is any of them, if it is a pipe or a redirection character, we have to go and handle those ones. So this means that we are going to be writing functions. Here, we'll need to write a function that does wildcard globing. So that anytime there is a wildcard detected, that function will be called to come and do its work. Then here too, anytime we identify a pipe, the function to handle pipes will be called to come and do its work. Anytime we identify some form of redirection, the function responsible for redirection will also be called to come and do its work. As soon as we are done, we'll now pass it to the executable itself. So where we are going to execute it. So now we come to the point that what we are dealing with, is it an executable, as I was explaining earlier, or is it a shell built in? If it is a built-in, then we know that we have written the code for it what to do. If it is an executable, the file already exists. So the shell knows exactly where to go and get it and run it. Okay, so if it is any of these, then we are going to execute it. But if it is not, then there is an error. So at the end of the day, it means that we actually, where is my pencil? We actually read from here, okay? Then we try to interpret and tokenize from right after reading. Tokenize what we have, then we now start checking. Check the command that we have, is it exit? No, because if it is, we want to terminate. If it is not, let's proceed. So the person didn't write exit, let's proceed. In fact, even here we will check for something we call end of file character. Okay, so there are a few checks that we will be looking at. Did the person press Control D? That means they want to end. Control D. Or did the person press Control C? Like all those things, we have to look at them. In fact, some of them we call them signals. We have to be listening for signals if there are any signals coming in. Then, if there are nothing to show that we should end it, we want to go ahead and check, is there a wildcard character in here? If there is, we know what to go and do with it. Let's call the function that is responsible to deal with it. If there is not, then let's pass this to the executable, like the phase where we're actually going to be executing. But first of all, we also need to check whether there is pipes or redirection. If there are pipes or redirection symbols or characters, we have to call the respective function to also operate on them. Then we'll come and check finally what we have. Is it an executable or is it a shell built in? If it is an executable, we know we should go and pull the file to come and execute it. If it is a shell built in, then we know exactly what to do because we have explicitly written the code to do that. If none of these, then we are going to display an error. Because that's when you say that this command has no exist. You've checked all these things that you were looking for, that you are aware that a shell or the bash shell knows of, but they are not any of these. So you go ahead and display an error. Then you send a person back to the prompt for them to enter a new command, just as you experience when you are using your shell. But if you find out that it's any of these, whether the executable or the shell, then you go ahead and execute the command. After executing the command, then you are going to display the output to the end user. Once the output to the end user is displayed, then you can end your program. So basically, that is how the shell in general works. We are now going to be zooming into them one after the other and ask ourselves, how do we get the prompt? How do we tokenize it? Okay, how do we pass it? Or how do we even do all these checks? The reality is that for us to achieve this thing, we need every concept. Can I say every or almost every concept that we have learned in C programming? And that's what makes it challenging. That means that we have to open our eyes, because now we'll be talking about functions, we'll be talking about arguments, that is command line arguments, we'll be talking about pointers, we'll be talking about functions to pointers, struct, name it. Anything that we have learned, like we are going to be using it here. So we have to open our eyes. In fact, unfortunately for us, we also do not have access to the standard library functions, like the common ones that we'll use, printf and co, because the project restricted us to a certain number of standard library functions that we can use. That means any other standard library function that we can that is available but we are not allowed to use, it means that we have to create our own copy. So for instance, we may need a function like string copy, but it's not part of the functions that we are permitted to use. That means that we'll have to write our own string copy function. If we need a function like putchar, we are not allowed to use putchar, so we have to go ahead and create our own putchar. So that is where the biggest challenge is. But it's still not a problem. What I am thinking is that we should just focus on building the shell with the normal standard library functions. As soon as we've been able to achieve that, we can now take our time to rewrite them, because now we know that, oh, our shell is working. Is it not string copy? Okay, so we need to rewrite string copy. I think that would be easier. Well, what do you guys think? Because otherwise, I don't see how easy it will be.
Wait, though, we are not going to use all those standard library stuff. I didn't even go
Yeah.
through the
Well,
whole stuff well.
they are limiting us to the ones that we can use. Let me open projects.
Oh, I was thinking I'm going to use not use printf putka.
As we have been
Oh.
doing always, it's only
Yeah, when they
some of
say we
the
should use
things.
underscore putka.
Mhm. So list of allowed functions and system calls. Let me go to P. You realize that there's no printf here. We don't have anything like printf. So it means we can't use printf in the project. You can't use putcha in the project.
Right.
The string function, string copy and code, we can't use any of them. The only ones that we are
The only
allowed to
thing we
use are
can
these
use
ones.
all those access
So
close get PID get line.
so any other thing that we are going to use, we'll have to create it by ourselves. Okay. Once I've opened this, let me mention something here to help us. I'm here to even do it, but to help us all, what we should do is let's understand all these functions and what they do. Okay. It would help us a lot for us to, sorry, why is this thing? Okay. VM, let me open my virtual machine. But basically, how you go about it is just open a Linux system, copy this, man2 access, then just put it there in a Linux system. But they are online. Why? Some are available online as well. So I don't know why this is not working. Right. Is it my network or what? No internet? So how come you people can hear me? You say I don't have internet, but you people can hear me.
That should be from the
Uh,
browser.
Interesting. Okay, so let me try and open my terminal. So that would be our assignment for today. Okay, let's go and for each of those functions there. Oh, this thing. For each of the functions there, let's go and check the man pages for the function. Intro. Okay, now we can go back to this. Copy this. Okay, so access. This is the format, and you should pay attention to the header files. So it means that we can't use this function without this header file. Okay, so when you run it, you take notice of the header file that we are going to use. Then this is a prototype of that function. That means anywhere you are going to use it, it should be in this form. But the question is, what does it do? And what is this path name? What should I even provide it? Then what is the mode? Okay, so we'll come on to read the description. It says that access checks whether the calling process can access the file path name. If path name is a symbolic link, it is dereferenced. So this is mentioning a lot of things here that you would have to start looking into. The path name, like that's like the name of the file that we are looking for, okay? But probably we are looking at a link, the path. So if it is in, let's say you have created 3 directories, each of them is inside the other. I mean, like one is inside the other, like that. You have to state, let's say I created on this my machine, I have projects, then I have C programming, then whatever file that I created. So we can pass it as such, or even sometimes just the name, right? But there is what we call the hard link and the symbolic link, where the hard link is usually like the full path, as I was saying. You start from your folder project, or maybe from even the hard disks, C drive, this, and finally that, all of them as a path. Okay, then you pass it to it. Or there is a symbolic link where it's just like you summarize it, but the computer understands exactly where you are pointing to. So let's try and read on this one to symbolic link to be able to appreciate what this is. Then the mode specifies the accessibility checks to be performed, and it's either the value of FOK or a mask consisting of the bitwise or one of them. In fact, I haven't read on any of these ones, so I can't really say much about it. But that's why I'm giving it to us as an assignment, so that hopefully when we start writing or when we start coding, we'll be able to know exactly what each of them does and how it does it, so we can make the necessary recommendation. I hope that makes sense. Let's, at
I,
least if
I
today
think
you
the
don't learn
return
it. Mhm.
the
You go
return
without
value is
it.
also important.
Yes, yes, yes. It's very important. The return value is very important. So usually this is actually a lot, but when you read down, you see the return value. It says on success, all requested permissions are granted, or mode is FOK, and the file exists. Zero is returned. So this is what the definition of success is. So on success, we return 0. On error, that's at least one bit in mode asks for a permission that is denied, or mode is FOK and the file does not exist, or some other error occurred. So this is what the definition of the error is. -1 is
That's
retained.
one.
So we have to keep that in our mind. So at least if you don't know anything at all, you should read on what header file we need to include, the prototype, then go to the description, at least get an understanding of the description, then check the return value for each of these. Okay, we need to do it for all of them, because once they have provided it here, then there is a high likelihood that we are going to need it. Okay, for that matter, we need to be aware, this, what does it do? This, what does it do? So I think this particular one is what will help us do the change directory. Okay, help us implement the CD. What does this do? What does this do? What does this do? So at the end of the day, these are the only functions that we have access to. Any other function that we are going to use, we have to create it. For that reason, we need to understand what each of these does, so that as soon as we start discussing that, okay, we need to implement this. Let's say now, how do we even read the command that the person wrote? Then you will come and tell me that, oh, according to the commands that we were given, this particular one, get line, can be used. So let me quit this. Then let's run get line. This is the header file we need to use. And here are two possible. Okay, so we'll use this one. This is the prototype that we'll use. Then when you get it, it says it reads an entire line from stream. So that's like the interface that you have shown. What is there? What is being written there? It reads an entire line from it, storing the address of the buffer containing the text into a line pointer. The buffer is not terminated and includes the new line character if one was found. So basically, all this is saying is that anything that you have written, I'm going to read it. So as soon as the person hits enter, we've read everything with this function. But what does this function return? On success, it returns the number of characters read. That means that if I am interested in knowing how many characters the person typed, then I should get the return value of this and pass it to the number of characters that were typed. Okay, there's a mention of a delimiter. We have to see what that delimiter is. What is it? Okay, and all of those things. So I think yes, that's the basic introduction that we have for today. Any concerns? Any concerns?
No, there's no concern. We just have to do a lot of reading. That's what I'm seeing here.
Yeah, yeah, sure. So hopefully, let's tomorrow we'll start by working on the part where we are going to read a command. Okay, read a command. At least, okay, tomorrow let's focus on reading the command and tokenizing it. So, or probably we'll just look at reading the command and what we can do with it. Once that one is done, then we'll take a look at something else too. I don't want it to be like one long session that will come and we don't get anything. In fact, it's not as if like I know it and I'm coming to teach. This is different. This is we coming to brainstorm. So here I'm just sharing the understanding I have about the project and what it requires. Then the actual work begins. That means that we are all going to put heads together to get it going. Okay, so tomorrow hopefully
Okay.
we'll look at how to read a command. So if for nothing at all, kindly read on get line. Okay, read on get line. Let's see exactly how it is used. Then read on this too, because we will need it when you are reading. If there is any error, we will need to know it. In fact, I recommend that we read all of them. Like try get time to read all of them to get a fair idea, because we will keep mentioning them, to get a fair idea of what they do. That's what I'm going to be doing. But more importantly, for tomorrow's meeting, we need this. Then we need this. Uh, okay, at least
It's
those are the
strength,
two.
strength,
Okay, we may,
strength talk.
if we decide to do the tokenization tomorrow, we may need this one as well. Okay,
It's part of read. We talked about read.
read.
I think there's read.
Yes, read to is here. Read and write. It's like, in fact, we've been using write for some time now, except that we hardly pay attention to it. When you write your underscore pucha, this is what you use to write it. You use
Yeah,
write your underscore pucha. So if you want to
yeah.
read, you can use read to write a function that will work like scanf, something like that, or put is it yes, scanf, or get is those ones you can use it read to write them. So they may come in handy along the line, because we'll need to recreate some of the system library functions, or with the standard library functions. We need to recreate them. That is when we would make use of these ones actually. Okay, but for the work that we are going to do itself, we need to also appreciate what a process is. What a process is. And I think I've explained it in a previous PLD where I said that when you write your code, the code that you've written, the executable, is called a program. And your program is stored on your hard disk. Like right now, you save it somewhere, maybe on your desktop. It is stored there. But when you are about to run the program, there is sort of a move from the hard disk, let's say a copy or a pointer to it, something like that. But it is moved onto the RAM. So whenever a program is moved to the RAM, it ceases to be a program. It's now a process. So let's pay attention to that. That's what we need to appreciate. your program that you've written, it will be moved to the RAM. It's going to take a specific memory location in the RAM. So if you have forgotten, then you should also start looking at the memory layout for your programs. I think the first dynamic memory allocation POD, that's what I discussed in the where the code section or the test is, like how the layout of the memory is. Very important. Where we have the heap, the stack, and co. All those ones comes in once the program has now become a process. Then the funny thing is that to be able to implement this shell projects that we are doing, you have to be able to create copies of processes at one point in time. So that's when we'll be talking about forking. So that one will also come inside. That means that if you don't understand what the process is and how the whole thing works, how a process works, it will be challenging for you to understand what forking is doing. Okay, but let's at least I think we have up to next week, right, to finish the project. So we'll take it one after the other so that we'll all be on the same page, we all understand it. Any questions before we bring today's session to an end? Okay, no questions, I presume. So please,
Doc, please,
assignments, let's
can
try.
I
Okay, yeah.
can I start your flow chart again? I was trying to write it down.
Oh, I would definitely share it. I'll share it. I think
Okay.
yesterday I downloaded it as an image, so I'll share it with you in the group.
Okay, thank you.
Welcome. So please let's not forget the assignments. Then some of the things, if you want to understand them, you realize I shared what was it? I shared
A tutorial, a video.
yeah, a playlist,
Mm,
in the WhatsApp group. So that's where I am getting my understanding from. I watched. I haven't been able to watch all of them, but I've watched majority of the lessons about forking. In fact, I started reading them, but I wasn't understanding them until I was watching those videos. So I recommend that when you get time, at least try and watch some of them. And the easiest way to build a product is if we go ahead and I mean look at what others have done. Okay, that's what will help us. So if you look, I have this. Oh, I'm not showing this. Oh, sorry. I thought I was showing that part of my screen. Okay, so here I have a personal Telegram group where I put my resources that I come across. So this is a lot of research that I did, and it's all about people who wrote some shell. Okay, so we have to get ideas from what they did, how they went about doing it to help us do ours. Because you can't come up with it on your own if you have no idea about it. Like now it's a standard. It's different from the first person that built it. The first person that built it probably didn't have any standard. So they had to come up with everything. But you are looking at a standard to replicate. So now you have to understand how the standard is, how others have been writing it, then you'll be able to write yours. Okay. So if possible, or right from here, I'll probably share all these links in the group so that we all can have access to it and watch some of them. All right, thank you for making it for today's meeting. Hopefully, we'll meet tomorrow, same time too.
okay, thank you,
Okay.
Doctor.
Okay,
This has
tomorrow
been really
tomorrow the same time.
Yes, please, same time.
okay.
Okay,
You're
Doc.
Thank you.
welcome.
Thanks a lot.
Thank you
You're
very much.
Thanks
welcome.
a lot.
All right. Bye bye then.
Yeah.